matter. That was an announcement, so we did the announcement. We know the announcement. We're okay. Let me start this. That was crazy. I think I know what happened. I left my computer in a car in 12 degrees below zero. And probably screwed something up. I will see. I hope I don't have to change the computer. Anyway, so let's open up the joke again one more time. Okay, so I was saying, what? Yeah, so I was saying an experienced programmer wrote this. An expert wrote this. Can anybody explain what's the joke?
Expert do as easy as possible.
No, as fast as possible. Okay, so beginner doesn't know what repetition is, writes like that.
Be sure this is cyber.
I don't think so.
You want to do something. Oh.
Anyways, we'll see. It happened to me before. I don't think it is. This computer doesn't do anything to be cyber attacked. We'll see. If it goes bad, then we'll do something about it. Doesn't matter. I'll go old-fashioned with the marker and stuff. I can. I'm an old guy. I can do that. Anyway, so yeah. So that's what I'm saying. First, learn, and then know where to break them. This is faster. This is not. Okay. So that's that, and I have to keep saving as I go through it over and over. So now we are going to talk about operators, understand what operators are. And the solution is closed for some reason. View. Oh, my solution is okay. Is it broken? The solution? One or more projects were not loaded correctly. Please see the output for the yada yada. So yeah, I have to recreate it. I'll do it in a second. It doesn't matter. Oh, actually, wait. Let's see if Git's gonna come to help. Ta-da! Okay, so that's what's good about Git, eh? Okay, so let me add existing items and add these two and immediately save in case it goes bananas again. And we'll come over here. And so that's the main for the, I'm going to say int a, int array main. It works the same way. It's not, there's no difference with it. So, oh, start it again. Seriously, the heck is going on?
If you disable the digitizer from control panel.
I don't know how to do that.
Disable.
Let me see what's going on. Seriously? Give it a second. You don't see what I see over here. Okay. Let me just.
Maybe inside device manager you can.
Give me a second. And God created ChatGPT. How can I disable my touch screen in Windows? And what if we pause the recording while doing that? And now we're going to see it's going to still do it. Okay, so let's talk about operators. Now, it closed all my cheat sheets over there. Let me just open it again. Yes. Okay, so I'm going to go. Sorry about that. I don't know what happened. But anyway, so let's create a file over here. I'm going to add a new item. I'm going to call it operators.txt. So operators. Okay, and I'm going to enable the. Okay, so we have this over here too. That's good. That's good enough. Get a marker. So in case I want to write something, I have it available. I guess you know that we're not going to have a break today, right? All right, and what's the time? 33. Class ends at 45, right? 12:40, 12:30. So set an alarm at 12:20.
There, your alarm set for 12:20 p.m.
Okay, so I need that. Okay, so assume that I have three different types over here, A, B, and C. Okay, type A, type B, type C. I have three, and I have three objects created out of it. Integer I, employee B, double C. Okay, you're okay with this? Do we understand what I mean when I wrote that? Okay, now we want to understand and see what are operators. When we are dealing with operators in C language, we have the most common one that we call a binary operator. It doesn't mean that it does binary like zeros and ones. Of course, everything's zeros and ones in computers, but it means the operator has two operands. So I can say A, and I'm going to put over here @ sign. @ sign is not an operator. So I put it over there as a placeholder. So I'll go A @ sign B. That means @ sign is an operator that accepts two operands. So A and B are operands, are called operands, and that @ sign is an operator, like A plus B, A minus B, A multiplied by B, A divided by B. Are we okay with this? These are called binary operators. They have two hands. Any operator in C language gets the left and the right, does whatever is needed, and it returns something. All of them do with no exception. That's why you can write code like that's perfectly valid. What does it do? It says A is equal to 3 greater than 4. What greater than does? It's a binary operator. Its job is to get the left side, see if it's greater than the right side. If it is, it returns true, which is 1. If it's not, it returns false, which is 0. Is this true or false? False, so A will be 0. You understand that? Okay. So the examples for this will be, so again, as an example, A and B are operands, so that's the operator, A plus C and C minus A. That's the example for it, and this is another example for that. So all operators return stuff. The binary operators have two different types in C language. One has side effect, and the other one doesn't have side effect. What does it mean when I say it doesn't have side effect? Take a look. All these stuff that you see over here, when these operations happen, plus, minus, yada, 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 when these happen, okay, nothing happens to B or C afterwards. B and C remain the same. Are we okay with that? Okay, the rest of the stuff, let me remove it. It's just the things that I have written down we don't need to talk about. So B and C remain the same after the operation. These are binary operators with no side effect. Essentially, the left and right are constant stuff passed to it. You don't change them. It's treated as constant values. Are we okay with this? Now you've got to say, what is a good example for a binary operator that does have side effect? There you go. It has a side effect. It's a binary operator. Its job is to take the value of the right one and put it into a left one, right? Therefore, it has side effect. And you can always take its value and do something about it. Again, like any other operator, it returns something. I can say C plus, and that is a perfect thing to write. So I have to write it with one more thing over here. D type D. You can do that. There's no problem with this, right? And or not necessarily it has to be different types. It's could be anything, right? Are we okay with this? So this has side effect. What are the other operators that have side effect? It changes the left one. No, that's not binary. Does it have two things? No. You know it. Huh? No. Huh? No. Although I'll give you that, but no. Seriously? Plus equal. Right? You write, don't you write A is equal to B plus equals C? You write that, right? That's a binary operator. What does it do? It changes the left side. It's not like assignment, but it still changes it. So from what we know over here, we understand this type of binary operator doesn't change the right one, but it changes the left one. Okay? You have to identify, not necessarily that's the case all the time, but you need to realize that. So are we okay with this? So binary operators, that's it. With side effect, without side effect, we're all through it. Next, unary operators. Unary operators are operators who have only one operand, not two. One operand, not two. Like you were saying, A, so A is equal to. This unary operator doesn't have side effect. Why? Because B is not changed afterwards. I'm telling stuff to you that is completely obvious to you, but we have to just categorize it. Why? Because we're going to change their meanings. C++ is a polymorphic language. What does it mean it's polymorphic? What is polymorphism? Many ways to do the same thing, right? So if I have minus p, I can change the meaning of minus p if I want to. That's what C++ is, and that's what the subject of today is, to learn how to redefine these operators. And we'll do. Don't worry, it takes 2 seconds. It's very simple, actually, no problem with it. So that's the unary operator. Now, if I say A is equal to plus plus B, now that's a unary operator, right? But it changes the value of its operand. Therefore, it has side effect. So this is unary operator with side effect. And without side effect. And this is with side effect. Our A is set to minus minus B. And this could be A is equal to not B, for example. We okay with this? These type of unary operators are called prefix because they come before the operand. And that's what normal operators in math and world do. It's only C++ that goes bananas and introduces a postfix unary operator. There are only 2 of them. We don't have any. There are only 2 of them. We don't have any. I repeat, there are only 2 of them. We don't have anything other than that. And that's plus plus and minus minus. Okay? So postfix unary operators are and remember, all the things that you had in C language that it says, this happens before the line, and this happens after the line, right? Down the garbage. We don't care about that. Those are behaviors of the operators. When you change their behavior, you have to define how they work. You have to define if it's going to happen after or it's going to happen before. So therefore, don't think about those things. The only thing operators keep is their signature, is what they are. Okay? I can make a plus operator do multiply for me if I'm nuts enough. Don't do that. We're going to teach you to change what they mean, but let's not go bananas, because that just confuses the heck out of people, right? So, and another thing it is, what is the meaning of overload? Overloading a function. Somebody. Should I take the microphone and pick someone? Can somebody be my hero? What is the meaning of overloading? Overloading a function? What does it mean? Same different parameters, which means you must have a function to change it, correct? You cannot say, I'm going to overload a function that doesn't exist. That doesn't make sense. You're not overloading anything. You're creating a new function. Overloading means I have a function. Now I'm going to make it do something else. Are we clear on that? You cannot create a new operator. I cannot make @ to be an operator from tomorrow, because it's not an operator. An operator overload only overload an existing operator. So you cannot invent new ones. Okay? Anything that is an operator can be overloaded. Are we clear on that? Are we clear? Okay. We have other types of unary operators too. Like we have this. It's kind of postfix, this operator that I'm about to write. That's why I'm writing it over here, but it's weird, that's why. So if I write over here, A is equal to, what are those square brackets? I'm essentially applying something to B, right? So that's an operator that accepts something in here. But it's kind of binary, not unary, because it accepts two things. So should I put it in binary, or I'm just going to write over here index operator? Okay? So that's one. So that operator changes something, right? Another one. I write A is equal to B type A1. It's kind of a prefix operator, which is essentially casting, right? Or I can do it like this so you're more familiar in C. So I have a type. I'm saying integer A is equal to double in parentheses and something else to convert it to a double. So I'm casting that. That's an operator. It's changing the value of something and returning it, exactly like any other operator. Okay? So we call it type conversion operator. So you can make casting an object to mean something. So if you cast an employee to an integer, the employee number will be returned. Right? If you cast an employee to a constant character pointer, their name is going to pop out. You can do that. Not that you should, but you can. So these are all the possibilities that we have. And all we need to know is how. Now we know all of it. There is one more that you're going to learn in 3, 4, 5. Maybe more than one. One more operator over there, but it's too rich for our blood at the moment, so I'm not going to mention it. Okay? But these are all the things that we have. Are we clear on what operators are? Okay, and their categories? Oh, you're just tired. I thought you were about to. Okay. All right. Are we good? Questions? Suggestions? Somebody's making rice. I can smell rice being cooked. Anyways, or maybe something's happening to my brain. I don't know. Are we good down to this point? All right. So I'm not going to jump into int array right now and do something with that with operator stuff. I'm just going to create something very simple first. And I always do that. I create something like, say, class container. And I'll put over here int value. So container is containing a value. OK? And just give examples on that. Public container int value. A new way to show you how to initialize the values. You can initialize the values in what I call initialization area, which essentially means, actually, no, let's not do that. OK, m value, we'll talk about that later, is value. OK, so I'm setting the value to the value which is in container. And I'm going to say if they don't mention what it is, it's going to be 0 by default. Are we OK with this? OK, easy breezy thing. Then in here, I'm going to say void display const, obviously, because I don't want to change my object. And in here, I'm going to say cout. Now, I'm going to say over here c dash m value. So we know this is actually a container being printed. Are we OK with this? Are we OK? Everyone? Oh, good? Now, let's add values to the container. So in here, I'm going to write void add. And in here, I'm going to say int value. So what am I going to do in here? I'm going to say m value plus equal value. Are we okay with this? Okay, so let's test this beautiful program of mine. I'm going to create container C. Okay. Now I'm going to say C.add 10. Oh, actually, I'm going to say C. Now I'm going to say display. This, come on. C.display. And I'll go C out and L, right? And in here, I'm going to say C out, C display again, and C out and L. Are we OK with this? So when I run this beautiful program of mine, 3 years later, it's going to say C0 and C10. Are we OK with this? I hate this. Why do I have to type, put C out? I want to write it in one line. OK? Wait a minute. Isn't display printing something on C out? What is a C out instance of? C out is an instance of console output, which is O stream. C in, we mentioned it, is I stream, right? So I'm going to write over here O stream. Oh, wait, what are you doing? I'm going to write over here O stream reference, and in here I'm going to say return. Right? We know what references are. So now my display will return the C out. Right? Which means display becomes a new name for what? C out. So in here, actually, B container So now in here, I'm going to say O stream reference. I think it's going to be an error because I forgot to take the return out in that one, didn't I? Yeah. You would compile and say, what the heck is that? Anyways, so now I'm doing this. See what I'm going to do? Done. Display and go to new line. Why do I have to write a C out? Make your life easy. OK? Whenever you are returning a function that returns void, whenever you have a function that returns void, you are losing an opportunity. Return reference of something that makes sense. Even if you don't use it, I can still say C.display and then go C out, whatever. I can do that. And C.add, or now that I'm doing that, I'm going to actually create another one over here. So I'm going to say void reduce int value. And I'm going to say m value minus equal value. OK? So now let's reduce it. So I'm going to say over here C.reduce by 5. OK? And C display after reducing. OK, so when I run the program, it still works. Because I am returning the O stream, it doesn't mean that I have to grab it. I'm returning it. Who cares? Like if I just, it's just a reference. It means the display is C out, but I'm not doing anything with it. Are we OK with this? Are we OK? We good? Hopefully. All right. I want to be able to set too. So I'm going to say void set int value. So essentially, it sets it, right? M value is value, right? I can set it too. Are we OK with this? So now in here I can say C dot set to 200. And I run it, now it's actually setting it to 200. Are we okay with this? Anybody have any problem down to this point? What if I immediately want to add something after I set it? Wouldn't it be nice if set could return C? Then I could just do this. If set could return C, I could just do add afterwards, right? It can't. What do I need to do in here? I need to return the reference of container, right? But the problem is that set should return the reference of the objects that's inside. What's this class? What's the number of this class? It's 244, the number of this class. It's C10, B1081, right? This class is, right? So when I say, are you guys in this class, do I need to mention its number? No, you know you're in this. But if I go outside of this class, I have to say, go to B1081, right? But when I'm here, I'm going to say, tomorrow, I'll see you in this class, this with double quotes. So when you are inside something, you can refer to that something by the problem is that C doesn't want to make it easy. Okay. So this is not this class. It's the address of this class. So if you want its reference, what do? An asterisk, target off beside it. So now that works. Now set is called, returns this. Who's this? C. It comes out, then add goes in. Now, it would have been nice if I actually did that to all these guys. Why? I told you, whenever you are returning void, you are missing an opportunity. Always when it's void, remember, even if we don't mention it in a workshop, we say return void. If it's a member, don't listen. Just make it return the reference of the current object. That makes your life easier later on. Now I can say, and then display. And then go to new line. So what's happening in this line? Set sets it to 200, returns this. C is returned, right? C goes with add. Add is added to whatever it was, 200, correct? Returns this. C is returned, right? C goes to display. Display goes to C. Displays 210. O stream is returned. And L goes to O stream. New line is printed. Wow. Right? So now if I run this beautiful program of mine, it just works. It's C++. Beautiful, right? So you can do good stuff. Ladies and gents, I'll be okay with this?
This has have side effect, right? All of them.
No, it's not side effect. It's called, what is it called? No, yeah, chain reaction is right, but not chain reaction. Cascading effect. That's called cascade. So you can cascade back to back. It's like a dominoes effect. One falls on the others and keeps going. But sometimes dominoes go to dominoes. But sometimes those dominoes, have you seen those things that they do and the dominoes goes and hits the thing and the car door opens and then the car hits the thing? You can do that. So it doesn't have to always return the exact same thing. They may return other stuff, but they could.
Another question, sorry. Can you add the end line to the display too? Like cout?
I did that.
No, end line.
To what? To C here?
To the display. For example, no.
inside the function? No, then you can never display the container between two things. I want to have the container between two things. I want to say C out come on, Farda, you can do it. The container has C.display in it. Okay? When I run this, you actually see that, correct? But, let me just put that and L over here. If you put the and L in here, then you're screwed. Has in it, jumps down. You don't want that. Okay, you don't tie yourself. You don't force yourself to be stuck with something. Okay? So we don't want that. Are we okay with this? Now in 5 minutes, I'm going to teach you operators. Okay, so this was this explained. All right. I have a question. Oh, and let's actually do something else in here. I'm going to write another AND. Add. In here, I'm going to receive const container reference C or other. Okay? Then in here, I'm going to create a container return. And in here, I'm going to have the value set plus the value of the other. And then I'm going to return that. First of all, I cannot return a reference anymore. I cannot return a reference anymore. Why? Because ret is inside add, correct? Reference means new name for something. So if I return a new name for ret, when add is over, ret will die. You're returning the name of a dying thing? It's like, say, go, Fardad's going to teach OOP244, 345 next semester. And you go, say, Fardad's dead. What does it mean? I'm not going to teach it. That's incorrect referencing, right? It's the same thing over here. When it's past, so you can never return, reference of a local variable, ever. You only can return a reference of something that's still alive after the function is called. Is that clear for everyone? So what this add function, this add thing is going to do? Very simple. It just adds. So I'm going to say over here, container B 10 and container C as 20. Okay? Now I can actually say over here, C is equal to B.add C. Okay? This add will not change C or B at all. And returns at, oh, my apologies. I wanted to say, why did I put C over here again? A, B, C. This is D. So it's not B, C. Well, I don't know what I'm doing. Anyways, let's call that A. I'm out of order. I know. Bear with me, please. So if I say over here, I can say C.display is the sum of D.display, B.display. I know my brain is playing tricks with me. B.display and A dot display, correct? Are we okay with this? So when I run this program, you will see that after that is called, C and it's not calling C for all of them, container. Just want to make sure that that's not a C thing. Okay, so container that has 30 is a sum of container with 10 and container with 20. And they did not change. Do we understand this? Are we okay with this, everyone? Are we okay? All right. Now, let's analyze what I have written over here. This add has side effect. Correct? This add has side effect. And I could do something like this over here even. I could say A is equal to, right, C add, because it returns this, correct? So A would actually hold the value that it has. So C adds 10 to itself, okay, and then returns whatever. So this add function has side effect, correct? This add function does not have side effect, correct? Are we all okay with this? All right. A, B, C, D. Methods with and without side effect. Okay. Now let's clear that main before we get confused and just show you something cool. You see this add over here? I'm just going to copy the whole thing. So I have a question. What this add is actually doing? It's adding 10 to left one, right? What operator does that sound like? It adds some value to the value of the left side. Plus equal, right? I didn't do anything. I just changed the name of the function. Are we okay with that? I'm going to remove the other add. Okay? And in here, and let's do this, and in here, I'm going to say C is set to A dot operator plus equal, what do I write? 40. Okay? So 40 will be added to A and passed to C, correct? It's the add function. I just renamed it. Please realize that. Right? If I say that, I can say over here C out, C out A. And in here, I'm going to say, what do I say? What am I saying? What am I saying? What am I saying? What am I saying? I'm saying C dot display. And in here, I'm going to say C dot, no, A dot display, right? And you run it. Oh, I didn't go to. You see, that's exactly what happened. So 40 was added to 20, right? Are we okay with this? Are we okay with this? I didn't do anything. I just changed the name of the function. Now this is what I'm going to do. Done. It's the same. You can call an operator overload with its function name or with its operator name. Literally, potatoes, potatoes. Same thing. Are we okay with this? Now, when you look at this add, where you have a right side and a left side, and they are added, they are not changed, and something is returned, which operator that reminds you of? You are passing two operands to an operator. It adds them up, returns them without changing the left and right. That's B plus C. It's just plus. So that's exactly what I'm going to do. Operator plus, if I can type it, right? And then you can again do the exact same thing. You can say B is set to A dot operator plus, let's go C. Correct? And if I do that, what happens? When it comes over here, B is passed with the value 10 to A, that is 60, correct? So 10 plus 60 becomes 70. Okay. Okay. Did I? Is it 70? Yeah. 70, and then 70 will go to C, but A and B remain what they are, correct? And if you run it, that's what happens. And it would be nice if I go to new line. Why am I not going to new line? And L. Seriously, my brain is completely out of. Okay. That's better looking, okay? So C is 70, A is 60, and B is 10. Are we okay with this? And that's exactly this. These two are the same. So whenever you put an operator, now container plus is not defined for it, correct? As soon as you do that, the compiler says, does the class that A is built of have an operator plus? If it has an operator plus, it calls it and passes the other one. As easy as that. You okay with this? All right, so that's binary operators. And if you run it, it works the exact same way. You know what's the funny part? Take a look at this. Did I implement that? Do I have an operator plus? Do I have anything like that anywhere? Do I have an operator plus that receives an integer anywhere? I don't, right? So how come it worked? What the heck? What just happened? How did it work? I didn't write any. Let me maximize this. I didn't write any operator plus with an integer in here. How did it work? This is what the compiler does. If you write integer A and B and you write A is equal to B plus C. What happens at line 63, people? What happens at line 63? Does that work in C language? Yes, it does. What happens? Yeah, it's going to cast. It's going to say C is 20. I'll cast it because I can build a double out of an integer, right? I'm going to build a temporary double out of an integer, make it 20.0, add it to 10.1. I'm going to have 30.1. I'm going to put it in A. Are we OK with that? Do we understand that casting, right? Now, take a look at this. So now that we understand this, I'm going to first comment it, because it's going to be confusing like heck if I... Now, what's going to happen over here? I have C is equal to A plus 900, right? So there is a 900 that's an integer, correct? And in here, it is receiving a container, correct? Does the compiler have a tool, have the tool to build a container out of an integer? Yes, the constructor. Because it has it, it says, OK, I can do that. I'm going to cast the 900 to a temporary container and pass that one instead. So all the rules of casting and stuff applies to yours, to your functions too. OK? The same thing we can do to reduce over here. So in here I can say reduce, and I can say operator minus equal, same thing. Set, what is set? Right? And you can do crazy stuff, like I can say container, just to tell you container reference. Give me an operator. What do I do? Yeah, operator multiply int value. And I can say for integer I set to 0, I less than value, and I plus plus. I'm going to say C out M value. Now in here, if I say A is equal to B multiply by 10, it's going to print. Again, these are just functions. You can do crazy stuff in it. Don't, but you can. So multiply is just an operator. Now I have news for you. You see this operator over here? It's called left shift operator. It gets the contents of a word in assembly language and shifts all the bits in it one to left. Or what they overloaded it, now it prints. That's C++. And we call it insertion operator. In OOP244, at the end of the semester, you learn that, hey, that's actually an operator from C that they overloaded it. We call it insertion, but it's actually left shift. The other one, extraction operator, that you get stuff out of C in, okay? That's actually right shift operator. Are we okay with this, down to this point? These are all called member operators. Member operators. Are we okay with this? Like any function in C language that could be a method or a stand-alone function, you can do the same thing. By the way, let's actually do this. I have to show you this before I continue. So first, let's remove this. Please, I'm going to comment this. So in here, I'm going to say, this is nuts. Don't do it. OK? But you can. OK? Just letting you know. Now, if I want to add 1 to a container, what do I do? Container reference operator plus plus, and I don't pass anything to it. Right? Because operator plus plus doesn't have a second thing. It's only one. So the owner is the operand. And in here, I just go mValue plus plus, and I return this. So I can simply do something like and it works. So by default, when you're doing an unary operator, it's always before. Okay? It's always before. Remember that. Okay? And how do I overload the right one? How do I overload this? Problem is that, wait a minute, these are both unary operators, right? So A is the owner of plus plus, correct? So how do I tell to the compiler that, hey, the plus plus is coming after? That one, the plus plus coming before. You know how to do it before because the default is before. You just do overload unary operator, and it's before. If you want it to come after, because the syntax of operator coming after, it's crazy in math, you have to do something crazy over here too, which essentially means doing this. That inth means nothing. It just means plus plus coming after. It's crazy. Has nothing to do with argument. It has nothing to do with what you're passing to the thing. It has nothing. That int only means plus plus is coming after. They had to come up with something. How could they differentiate between the two? And so this, so the int means nothing but postfix. So remember, it's nothing. Nothing is being passed. There's no argument, nothing over there. Now, remember, unlike regular one, when you do C is equal to B plus plus, A will first go to C and then plus plus happens, right? No. You just created your own function. It has nothing to do with that. You changed everything. If you want that, you have to implement it. We'll tell you how. But if you run it, it doesn't make any difference. It's going to just add one to it right off the bat. Okay? Now your job is to go review all these things and do all these beautiful stuff, and then the next day, it's not going to be a review. So review is going to be the day after. So the next day that is online, we're going to go through all different types of operator overload to the bone and apply it to our integer array. Okay? So please review these, and then we'll see what happens after. Are we okay? Are we okay, everyone? All right. All right. Have yourself a wonderful, beautiful day, and I hope your brains are not fried. Cheers, everyone.